Galaxies are categorized according to their visual morphology as elliptical, spiral, spiral-barred, or irregular. They are sometimes further divided into subcategories. If you are interested in knowing more about them, then watch this video till the end so you won't miss any. Without further ado, let's get back to the video. A galaxy is a huge collection of gas, dust, and billions of stars and their solar systems. A galaxy is held together by gravity. Our galaxy, the Milky Way, also has a supermassive black hole in the middle. When you look up at stars in the night sky, you're seeing other stars in the Milky Way. If it's really dark, far away from lights from cities and houses, you can even see the dusty bands of the Milky Way stretch across the sky. A system used by astronomers to divide galaxies into groups on their visual appearance is the galaxy morphological classification. Many schemes are in use in which galaxies are classified according to their morphologies. The most famous one is the Hubble sequence, devised by Edwin Hubble, and later expanded by Gerard Vaucouleurs and Alan Sandage. Originally, Edwin Hubble grouped galaxies into four main categories: spiral galaxies, barred spiral galaxies, elliptical galaxies, and irregular galaxies. Observations revealed that spiral galaxies were the most common type of galaxies found throughout the universe. 1. Spiral galaxies. They have a flat, spinning disk with a central bulge surrounded by spiral arms. The spinning motion reaches speeds of up to hundreds of kilometers/miles per second. This usually can cause matter in the disk to take on a distinctive spiral shape, like a cosmic pinwheel. The bulge located in the center is made up of older, dimmer stars, and is thought to usually contain a supermassive black hole. The disk of stars orbiting the bulge tends to separate into arms that circle a galaxy. These spiral arms contain a wealth of gas and dust. Thus, many young stars are birthed in these regions. These young stars shine very brightly before their quick demise. Spiral galaxies can be classified according to the tightness of their spiral, the lumpiness of their arms, and the overall size of their central bulge. The relative amounts of gas and dust contained within these galaxies can portray these differences. Andromeda is a perfect example of a spiral galaxy. 2. Elliptical galaxies. Elliptical galaxies have an elongated spherical shape and lack a nucleus or bulge at the center. Although there is no nucleus, the galaxy is still brighter in the center and becomes less bright toward the outer edges of the galaxy. Their light is dominated by older reddish stars. They appear to also lack spiral arms. The stars, gases, and other materials are spread throughout an elliptical galaxy. Elliptical galaxies can be nearly round or long and cigar-shaped. Though individual stars orbit the center of an elliptical galaxy, the orbits aren't all in the same direction, as they appear in spirals. Therefore, ellipticals don't appear to rotate in a systematic way. Theories suggest that a great deal of the mass in an elliptical galaxy is due to the presence of a central black hole. Elliptical galaxies have very little activity and contain mostly old stars of low mass, because their gases and dust, which is needed to form new stars, is quite lacking. Elliptical galaxies vary in size, from small dwarf galaxies to enormous galaxies. An example of a giant elliptical galaxy is ESO 325G004, while Leo I is a dwarf elliptical galaxy. An intermediate between the giant and dwarf elliptical galaxies are systems such as M32 and M110. They are companions of the Andromeda galaxy. 3. Irregular galaxies. Irregular galaxies have no definite shape, though they are in constant motion like all other galaxies. They have a chaotic appearance as they don't seem to possess a nuclear bulge or traces of spiral arms. Some irregular galaxies were once spiral or elliptical galaxies, but were deformed by an uneven external gravitational force. Irregular galaxies may contain abundant amounts of gas, and dust. Irregular galaxies are commonly small, about 1/10 the mass of the Milky Way galaxy. 4. Barred spiral galaxies. Although similar to spiral galaxies, barred spiral galaxies differ in their shape slightly. Rather than just being spiraled from the nucleus like ordinary spiral galaxies, these have a bar of matter running through them too. From the ends of this bar the arms emerge. This middle bar with the two arms extended from the ends of the bar causes barred galaxies to be shaped similarly to the letter S. Other than this major difference, barred spiral galaxies and typical spiral galaxies are essentially the same. Just like typical spiral galaxies, barred spiral galaxies contain a disk, bulge, and halo. According to Hubble tuning fork, barred spiral galaxies are notated as SB rather than just S or SA, as typical spiral galaxies are. Additionally, as noted earlier, the Milky Way is a barred galaxy. Barred spiral galaxies share the same features and functions as regular spiral galaxies, but they also have a bar of bright stars that lie along the center of the bulge and extend into the disk. The bright bulge has very little activity here and contains mostly older red stars. The bar and arms have lots of activity, including star formation. The perfect example of a barred spiral galaxy is our own galaxy, the Milky Way. They are further divided into three categories. Barred spiral galaxy type A, abbreviation SBA. They feature tightly bound arms. Barred spiral galaxy type B, abbreviation SBB. They feature both tightly and loosely bound arms. Barred spiral galaxy type C, abbreviation STUCK. They have loosely bound arms. Around 2/3 of spiral galaxies contain a bar structure through their center. That's it for the video. If you enjoyed it, kindly like the video and subscribe to our channel.